going to introduce you to our last guest speaker, Sofia Koukoura. And what's interesting about Sofia, well, one of the many things that's interesting about Sofia is that she was a PhD student. So we thought it would be an ETP PhD student. We thought it'd be interesting to get her back to find out what her experiences are post-studentship, because a lot of you will be wondering about that. So Sofia, over to you.
Hello, everyone. Let me share my screen first and set up everything.
And just let me say, of course, if you have any questions for Sofia,
do I have any rights to share a screen? Because I'm not sure I can. Do I have permission to, like, can you check as co-organizer if I, yes, I can see that now. Okay, good. So let me, I know now you're probably seeing my first screen.
Yeah, we've got your PowerPoint.
Yeah. Let me. I just want to make sure I share. Second screen. Yeah.
Ah, perfect.
Yes, now I'm sure it's working. You should see the full screen of the slides. Good. Hello, everyone. My name is Sofia Koukoura. Thank you, Stephen, for introducing me. And I now work as a senior asset performance analysis engineer at ScottishPower Renewables. I used to be a PhD student and at the University of Strathclyde, and I got funding from the ETP PECR scheme to do a couple of research exchanges. So I'm happy to be back in the ETP conference. I think I've been to every single one since 2016, I think, when I started my thesis. And yeah, it's been really lovely. I've met wonderful people. And today I'm going to talk to you about my experiences on my journey, basically from academia going to industry. And my talk is titled From Small Data to Big Data, which will make sense once I talk through it. So I hopefully, for those of you who are doing a PhD, I hope I can give you some ideas for your career path later on and the options you might have. And for the rest of the attendees, I hope that my talk and my story will further highlight the importance of why we need to work all together and collaborate in the energy industry. So just a brief background on who I am. So I am a mechanical engineer, started mechanical engineering in Greece, in Athens specifically, that's where I'm from. And then I moved to Glasgow to do a PhD with the Wind and Marine Energy Systems Centre for Doctoral Training at the University of Strathclyde. My PhD experience was really nice because I got to travel a lot through the ETP PECR scheme. So I did a couple of research exchanges, as I mentioned before, and I got to visit a research lab and a company. And I also went to quite a few conferences. So yeah, these were nice times before COVID. And then once I finished my PhD, I did a postdoc, continuing at the University of Strathclyde, where again, there was some overlap with ETP in the industry engagement scheme. And now I work as a senior engineer at ScottishPower Renewables. It's been less than 2 months, so I have some insight to share, but hopefully I can come back in the future and share some more insights, because yeah, my experience so far is limited, but I enjoy it. So my PhD thesis had to do with wind turbine gearbox diagnostics using artificial intelligence. So the main research question, without getting a lot of detail into it, was how we can predict incipient gearbox faults, so faults that are developing on a wind turbine, by using data streams, so a combination of all the condition monitoring data we have, all the SCADA data, and how we can process data and use some machine learning algorithms before something major occurs. And then that way we have big downtime, we have bigger costs for replacing parts, and so on and so forth. Large part of this PhD is getting data, processing data, and find smart ways to extract information out of it, and how to use mathematical machine learning models. Obviously, as you can understand, it's quite an applied piece of research, and as I've seen most of PhDs in the ETP scheme. But that's also a problem, because there is often this gap that needs to be bridged when you do a PhD and when you do your research. So basically, that's going from the theory to practice. You spend quite a few more months at the beginning, reading, diving very deep into the theoretical aspects of what you're studying. You need to be able to make sure that you fully understand all the theory and science behind it, because at the end of the day, you will write a paper or present a thesis that's going to be peer reviewed, and you want to make sure that your work is very thorough. But at the same time, you want to have case studies and examples, and that often can be difficult because, for example, when it involves data and you want data from companies, then information is often confidential, and that sometimes can be quite hard to get. So I was lucky that first of all, I got to visit a research lab during my PhD. So my first ETP research exchange was at the National Renewable Energy Lab in the States. So everyone, I think, who works in renewable energy knows how important the research from NREL is, because they have a lot of they have developed a lot of tools that has helped the industry. They disseminate their work really well, and I think pretty much everyone who works in energy must have read a paper or must have used a tool by NREL. So that was the first step for me to get a little bit of a more application and practical understanding of the theoretical research I was doing. So I got to visit Colorado in the US, which is lovely place, lots of nice mountains and nature. So they have this research lab. The main one is based in Golden. I was in the wind one based in close to Boulder, where they have a lot of turbines. I got to climb one, as you can see in the picture. They have these field test sites, and they have blade testing, drivetrain testing. So I got to go there and collaborate with the drivetrain team, which was really useful experience. And I got very good feedback for my thesis and was able to get some ideas on how to continue later on. So that was during my first year of my PhD. And then afterwards, the second PECR research exchange I did was in a company that's called Orsted. So it's a big utility in Denmark. It's the biggest offshore wind farm operator, actually worldwide. So that was an even more applied, let's say, piece of research. So I had developed some algorithms during my PhD up to that point. I had tested it on some small data sets. So the idea when I went there is to try those on a little bit of a bigger data set and try to help them develop some tools. So basically, we wanted to compare all the rule-based systems they were using. And by rule-based, I mean that when you monitor a system, you, for example, might check at the temperature and say, if the temperature is bigger than 50 degrees, there might be a problem. Like that's the main idea. So compare that idea to what machine learning does, which is a more statistical modeling, but at the same time, it's not that transparent. You can unlock a lot of value from your data, and you can automate your systems, but that's still under question from the industry because we're not sure if it works well or not. So that was a very good opportunity to test even further the algorithms I develop and get some further experience by working with industry. And for those of you who are working in research, I cannot emphasize more how important it is to try and collaborate with other research institutions outside the one you're currently working at. Either that is a research lab, another university, or a company. It's really valuable to work and engage with others so that not only you develop your hard skills on your work, like getting feedback on your thesis, but you also develop your soft skills and learn how to collaborate with others. I know times are difficult right now to doing visits, but I'm sure there are ways to engage with others, even in an online way. It's just useful to talk to other teams in your field a little bit more. So I want to talk about this project as well, which I worked on while I was doing my PhD as well. So I was a research assistant for a while at the Romeo Project, and I'll come back to it because I actually work on it as well now in my new role at ScottishPower. So basically, Romeo is a Horizon 2020 project under the Low Carbon Energy Fund, and aims to develop solutions that reduce operation maintenance costs of offshore wind. And as you can see, there are a lot of partners involved. One of them is Iberdrola that I work right now, EDF, IBM, University of Strathclyde as an academic partner. So all of those partners have a different expertise because offshore wind and operation maintenance costs is a problem that it's not like, it's a multidisciplinary basically problem that needs to be addressed, and solutions need to be provided by many fields. You need to develop good sensors, you need to have communication systems and online IT platforms, you need people who do the physical models, the more data models. So all these parties have gathered together to provide a solution to this problem. So I worked as an RA at the University of Strathclyde, where I developed a life cycle assessment model. And that was another good experience while doing my research. And I think it really depends on the person, but often when we do our PhD, we come up with an opportunity to stop it for a few months or work as an RA on something else. For me, that seemed like a nice opportunity. Others believe that they don't want to interrupt the study, so that's totally up to you on how you want to approach your work and your research. But at the time, it felt like the right thing for me to do. So I think that was really useful because I actually work for this project now as well. So after I completed my PhD research, the next step, which seemed like a very natural step at the time, I really liked being at the university, was to do a postdoc. So there are different funding opportunities you can get. One of those was the EPSRC Doctoral Prize, which seemed like a good idea at the time because it's basically a year of funding that you apply. You write a research proposal, you apply for it, and basically you drive your own research for that year. And that's quite a good start for your academic career because you start building your own research agenda and your own team. Another option would be if there is a research project already in place, maybe your PhD supervisor has funding to hire you as a research associate to work on a project and so on. So there are quite a few good funding opportunities to continue working your research after you do your PhD. And I totally recommend this one because it gives you the flexibility to work on the topic you want. So I continue working on a similar area as I was in my thesis, but I focus more on the prognostics part. The same way in a human disease, like you perform diagnostics, if there is a virus, you also want to say, oh, how long will I have this virus for? So same way for machines, it's like, how long do I have before something more major happens, let's say. So because this research has different, let's say, work packages and parts in it, I needed people to help me who are good at deriving machine learning models and have good data. I needed people who know more about physical modeling and signal processing, people who are experts in prognostics and uncertainty in that area. So my research was basically being kind of the middle person who could understand all those fields well enough, but I needed all these people that could help me dive even deeper and merge all the results together. And actually I had another research exchange lined up for last summer in the NASA lab in California, which would have been very exciting, but obviously it didn't happen. So even though I really enjoyed doing my postdoc, I felt like there was, I had a need for a change basically. So this really good opportunity at ScottishPower came up, and yeah, that's why I joined. Yeah, before I get to that, I want to talk about another part I worked on while being a postdoc. So that's the ETP Industry Engagement Fund, which basically a fund that supports Scottish SMEs and helps them develop their low carbon technology and solutions. So that's up to 10K worth of funding to provide and some consultancy services, and that gives them the opportunity to work with one of the collaborating universities in Scotland. So the one we applied for was with Offshore Survival Systems, a small company that basically provides services for helicopter operations offshore, and that way they hope they can increase safety and improve the yield and the levelized cost of energy. So that's a small company. It had this idea, but also needed some further knowledge in how to basically prove their business case. So we had these life cycle models in Strathclyde, and the idea was to help them make their business case. And that's something, yeah, I applied for just before I left Strathclyde, and now my colleagues have taken over on it. So if you want to know more, ask David Macmillan. But that's another good opportunity of how universities can engage with industry and how there are a lot of funding mechanisms in place that can help bridge that gap. And that 10K can go for, yeah, funding a researcher to do the work, which is nice. So yeah, now I've moved on to ScottishPower. I work as a senior asset performance analysis engineer at the monitoring and analysis in the global technical services. So at the beginning, I thought, oh, how could basically my research skills be translated in a more like industrial environment, a more fast-paced place? But I believe that, and from what I've seen so far, as researchers, we have some really valuable skills, but we also obviously have this imposter syndrome, which makes us believe that we're not good enough. But we have learned how to close the uncertainty in the work we do. We have learned not to be scared of the unknown, because we are often called to provide solutions and do research on something that hasn't been discovered yet. So these are all like skills that can be transferred, and obviously all the deep technical knowledge that each one of us has in their field. So yeah, in this particular case, the job requirements really matched my my skill set, and yeah, I'm really happy I joined. So the team I'm working in now is responsible for obviously doing condition monitoring for all the assets that Iberdrola has, but at the same time do this monitoring in a very cost-effective and robust way. And we support all the operation maintenance so that we basically intervene early when something is happening on the asset, so that we prevent catastrophic failures and higher costs and downtime, as I mentioned before, and prolong the life of our assets, and yeah, basically expand on the condition monitoring capabilities throughout the whole fleet. So the team that does the monitoring has different roles. Obviously, you need some more technical management and project management. And I work more in the area of data engineering, data science, and day-to-day analytics. So I went from small to a little bigger data, and now to so much data that I cannot really handle, which is an irony, because while I was doing my research, I really hoped I had more data, and now it's impossible to handle all of it. So yeah, my work is divided into doing some deep dive analysis, providing support to our O&M teams when they need further analysis on data and incidents that happened. I work on the diagnostic tools we have and improving all the alerts and systems that are in place. And I also work on some innovation projects. which is very exciting because it gives me the opportunity to still be close to research and university work. So yeah, as I mentioned before, now I work again in the Romeo project, but as an industrial partner. And this project is divided into a few different phases, and each partner is responsible for a different part of it. So at first we had the definition of the technical specification and all the project requirements, and then the phase 2 is more like developing all the monitoring systems and diagnostic solution, and then the third phase will be to validate it. So now my role is not as research oriented as it was in the university, but it's more like giving guidance and leading some work packages within Romeo and using my expertise to advise our partners. Another exciting innovation project I'm working right now is the MIT Green Guard project. So basically the purpose of this project is to bridge a gap between all the machine learning model development and full-scale deployment. So to make this more clear, I have this laptop right now. I can download some data and develop some models, but obviously it cannot handle to download all of Iberdrola's data every day and run the models and tune them. And yeah, this process has to be optimized and automated and basically make all the this statistical learning process easy. So that's what the Data to AI lab at MIT is doing for us. And that's part of it is an open source project, and you can also find it online if you want and find further information. But I find often that all the experience that I got through my thesis has been really useful in building this project, even though I had also a lot of things to learn of how these big data platforms work and so on and so forth. But I was able to advise more on how all the technical aspects and specification that need to be modeled within this project. And another thing that my team has been running, I take no credit for it because this happened long before I joined the company, but that's another example to see how industry can engage further with the public. So that was the Power Available Hackathon that happened just a year ago, I think, organized by ScottishPower Renewables and Catapult. So basically, ScottishPower had this data set that they provided to the contestants to solve a problem that basically they had, and that was like how you can use smart ways to calculate the power available in your site and how you can use data-driven solutions to do that. And that was, yeah, a really successful hackathon. It was also, it's on the finalists of the Scottish Green Energy Awards now as the Best Engagement Award. And yeah, that's a project that we are following up on. But yeah, the outcome of this hackathon was really good. So just some final, concluding thoughts based on experience so far from the energy industry and from academia to work in the private sector. So we often refer to that we need to tackle this whole climate crisis and obviously have a whole systems approach to energy in order to provide solutions. That's often highlighted. But at the same time, we also need to have a whole system approach to our whole energy industry. And that means engaging academia, government, private sector, working all together to find solutions to this problem. Each one has a different expertise and different skills, and I cannot emphasize more how we should work together. Having seen both sides now, both from academia and private sector, I think there is a lot of value into just collaborating with each other, just even not through projects, just talking a little bit more, getting insights from one another. And yeah, as ETP's mentioned and stated, that we need to basically make all this excellent research that is there in place and translate it into economic impact and environmental impact. And I think that's the only way that we can provide solutions to the energy challenge we face right now. So that was me. Thank you very much for your attention. Thank you for your time. Any questions?